Right. Good afternoon, everyone. My name is Daniel Kahnemer. I am from South Africa, from the South African Astronomical Observatory, and I'll be your chair for this afternoon. First up, we have Dorian Knight, who is from another Royal Observatory, maybe the original one, and we'll be talking about celebrating cultural heritage of astronomy at the Royal Observatory, Greenwich. Thank you, Dorian.
Hi, everyone. So, my name's Dorian Knight, and I'm the Senior Manager for Astronomy and Heritage at the Royal Observatory. And I'll be talking about our new and exciting plans for engaging audiences. Next slide, please. Just for context, the Royal Observatory Greenwich is in South London. It's the historic home of astronomy in the United Kingdom. It was built just over 350 years ago, commissioned by King Charles II to help British sailors navigate the oceans. The images show some of the varied activities just on the screen at the moment that are run at the observatory in the present day, including a program of lectures, observing evenings, planetarium shows, temporary displays, and courses for higher education. Next slide, please. So this year, the observatory is starting a once-in-a-generation transformation. Through this redevelopment, which is called First Light, which is anticipated to last until the spring of 2028, we will conserve, restore, and repair the interior and the exterior of the observatory. This is an architectural model of the new site. However, the redevelopment is not just about the building. The project will place people at the center of the story and encourage a new and more diverse audience alongside our existing visitors, and provide fresh pathways into astronomy through culture and heritage to supplement the existing science offer. Next slide, please. So following initial audience consultation to establish areas of greatest need, we define these new audiences as the following: formal school learners across all educational stages with a focus on access provision, families and diverse communities with children under 12 across the London boroughs surrounding Greenwich, young people aged 14 to 25, particularly those outside education and employment, and adults aged 65 plus with a focus on those living with dementia. Next slide, please. To understand the barriers those audiences faced, my team undertook a program of consultation speaking to over 60 institutions and 600 individuals that represented them. I just want to focus on the consultation feedback provided to the following three questions, which will hopefully be useful if anyone else here is undergoing a redevelopment of their observatory or looking to broaden their audiences. The first question was, what would your ideal cultural experience at the observatory include? The answers included diverse formats and duration. So respondents expressed their ideal experience may vary in length, from short half-day visits or evening events to longer engagements. This feedback emphasized the need for flexible programming. Immersive and hands-on experiences. Consultation here identified a strong preference for interactive, multi-sensory programming that goes beyond passive observation and includes tactility, visual stimulation, and role-playing. Balancing education with enjoyment. The responses here indicated that while educational value is important, especially for school groups, the overall experience should be engaging enough to inspire a more lasting interest in astronomy. And inclusivity and welcoming environments. In order to create an ideal environment, the feedback we got was that the venue and its events must be inclusive and accessible. Responses highlighted current gaps and the need to create spaces where visitors feel welcomed and included. The second question, what type of activity would you be interested in at the observatory? The answers we received flagged that interactive and hands-on activities were important. Consultees were interested in more opportunities for practical, immersive experiences rather than passive learning. They wanted to see creative, participatory formats like drama collaborations, guided tours with interactive elements, things like that. Sensory experiences, stakeholders highlighted the need for incorporating sensory elements that engage touch, smell, and sound. Accessible content and formats. This was flagged as crucial to accommodate users with diverse needs, including those with visual, hearing, and cognitive differences. There was an identified need to customize activities to suit different energy levels and build familiarity and comfort with the site. On to that next point, that the consultancies wanted integration of arts, music, and creative expression. This suggested interdisciplinary programming to enrich the visitor experience would be appealing. Then we have social engagement and community outreach. Here the team were recommended to develop events that encourage socializing, community building, and shared experience with structured yet relaxed atmospheres to foster repeat visits. And for the final point, consultees told us they wanted to see interactive technologies, experiment with VR, planetarium innovations, and futuristic and speculative concepts. And then just to touch on that third final point, what themes and topics would you be interested in at the Royal Observatory? Interdisciplinary exploration. Participants in consultation emphasised that any astronomy topic could be engaging if presented in an innovative way. They suggested blending disciplines, so science, music, art, and technology complement one another. Moving on to that second point, there was a strong recommendation to connect programming with local and cultural narratives. This included integrating local history, storytelling, and contemporary cultural perspectives to make the experience more relatable. Diverse and inclusive perspectives. This included suggestions to examine how different global cultures relate to the sky. And educational and curriculum linked programming. So respondents proposed integrating learning experiences through engagement with experts, such as Ask the Astronomer opportunities. So we took all this feedback on board and we've developed a program which I'll touch on briefly now. This is under development and it'll be fully launching when the observatory reopens in 2028. Next slide, please. So for families and communities, we have developed a program that provides opportunities for young families to come together, prioritizing their experience before learning outcomes. The first 4 activities here are for very young families. Little Stars is an astronomy storytelling session, incorporating music and movement, sensory play, and exploration. Starlight Sessions is a similar program, but specifically for families with access needs. TOTS Takeover Day, again similar, but on a larger scale across our sister sites at Royal Museums Greenwich. So that's the National Maritime Museum, the Queen's House, and the Cutty Sark. Astronomy Lego Club also provides the opportunity to explore astronomical objects through creating Lego builds. Astronomy Heritage Festivals, that's the first of the bottom points. These are large-scale festivals for families. This year we'll be celebrating the heritage and folklore of the winter solstice. We'll be running a cultural astronomy programming, exploring diverse identities within the UK's population, focusing on South Asian, African, and Chinese astronomy. And we'll also be opening the Royal Observatory up for tours, workshops, and shows in languages other than English, showcasing the observatory as a site of inclusion and belonging for London's diverse population. Next slide, please. We will also expand into a new branch of formal learning, offering a rich new astronomy program for schools. This includes storytelling, exploring astro myths and folktales for early years pupils, and sessions exploring both astronomy and the works of Shakespeare for English literature students, and astronomy, science, and the British Empire for history students. We'll hold a new lecture series to explore the diverse career paths from a range of astronomy specialisms, from astrophysicists and aerospace researchers to historians and artists. We'll be delivering a British Sign Language tour for students with hearing impairment, as well as developing new signs for our planetarium show content for people with BSL, who need BSL. We'll also be creating a version of the school program to provide educational resources for children and young people admitted to hospital. And finally, we'll be using evidence from this program to inform best practice case study of how to make historic observatories accessible. Next slide, please. For young people, this demographic includes those at risk who would benefit from meaningful and structured interventions. Over the course of the project, we'll offer practical heritage skills development and training, including structured learning programs around SciComm, where participants will have the opportunity to develop new skills, including increased confidence in public speaking, creative expression, and communication. We'll also be hosting work experience where we'll showcase the professional skills that go into making science fiction films and video games with the aim to inspire the next generation of video game and film creatives. Next slide, please. For the over 65s, this program will help to cultivate interest in our themes of time and space and tackle social isolation and loneliness through group programming. This includes a cup of time and space. These are informal learning sessions to stimulate curiosity and conversation. Specialist speakers will present on a range of themes from both the history and the science of astronomy. Time to make. This is an opportunity for participants to foster their creativity, share skills and make friends. This is inspired by our collections, where people can try their hand at astronomy jewelry making, calligraphy inspired by our astrolabe collection, or watercolor paintings. We have music at the movies. This will provide the opportunity to relax and have a drink whilst watching a vintage science fiction film with live musicians playing the soundtrack. And we will also develop reminiscence boxes for people with early and moderate dementia based on items with our collection themed around seasonal change and the passage of time. And then final slide. And then finally, we intend to stage the biggest astronomy and heritage celebration that the UK has ever seen. We want to work with high-profile artists who will create a network of creatives, musicians, poets, and performers to join with astronomers to break down barriers, merge disciplines, and celebrate time and space through events at different locations across the UK. The end result is currently unknown, but we do know that it will be bold, stimulating, inclusive, and most of all, fun. Thank you for listening, and it'd be great to hear any feedback for anyone who's worked particularly with artists and astronomy. Thank you.
All right, thank you, Dorian. We have 2 minutes for questions. I have not received one online. Sorry, thank you. We've got 2 minutes for questions, so Annie?
So that's a very simple question. How large is the group working on this project? So how large is the group working on this project?
Yeah, that's a very good question. In terms of full-time staff, there are 4 people, but we can tap in. No, sorry, there are 4 people right now. There will be 6 people full-time on the whole project, but there is also the wider astronomy team who will dip in and out, which is about 20 people. Yeah.
Thank you. Let me run.
A question and a comment. So the question is, do you have anything that's going to show sort of real-time data that you're incorporating into any of your displays or programs? And then the comment, because you were asking for feedback, is if you haven't already, when you think about artists to work with, I recommend working with perfumers, which is something that I have done. I'll talk about this tomorrow, but I'm also happy to chat because it's part of the sensory experience that you were talking about. And I've found that most that you try and work with are really excited to do so.
Thank you. Yeah, it'd be great to talk about that later. In terms of real-time data, there isn't currently a plan within this program, except perhaps for the national project. We're still kind of working out what that looks like, but there will be that will be delivered through the new exhibitions. So I'm just talking about the public program. The exhibitions is a whole different side of that will, yeah, definitely include real-time data.
Hi. So in your market survey, did you ask any questions about value for money, particularly related to price points and what people are prepared to pay to enter and get all of these valuable things?
Yeah, absolutely. It's a huge issue. I mean, we did. The observatory currently is very expensive. So as part of this redevelopment, which I didn't touch on, we will have a financial access offer. So offering really greatly discounted tickets to the site. But I would say that because of the funding, a lot of this is for free, so people won't have to pay. So we have a big grant from the National Lottery Heritage Fund, which if people who know the UK funding scene, are one of the major funders of arts and culture. So they provided a grant that will enable us to do this for free for at least 4 years, when we'll then reevaluate. Yeah.
All right. Thank you, Dorian. There is one question online. I don't know if you want to hop online later. We are a full session this one. We've got 7 talks to get through, and welcome drinks at the end. So I'm going to try and keep us to time. Thank you very much again, Dorian. Very exciting project. And so next up, we have Marcos Valdes, who will be talking about a hybrid multi-sensorial learning experience about the solar system.
Thank you. It's a pleasure to be here. Okay. Thanks to the organizers. Next slide, please. Just I have a lot of slides. I was counting on going very fast, but I will have next slide to say next slide, please, a lot of times. So, so just a brief introduction. I'm Marcos Valdes. I'm an astrophysicist. As in 2014, I was doing my one of my postdocs at Scuola Normale Superiore in Pisa. We won a grant by the Ministry of Education to start an outreach project in Scuola Normale. We didn't have one at the time. So we started this virtual immersions in science because we knew at the time that there were these new cool technologies for immersive visualization of scientific data, among which virtual reality, augmented reality, and so on. And the project went on until 2018. It was a great success. Next slide, please. And we decided after 4 years to take the thing a step further and to create what we wanted to show to the people. So we had a lot of activities. We wanted to show really cool content. And so we decided to try to transform what is often considered dry, difficult, you know, kind of something for nerds into something really fascinating and engaging and so on. And so, next slide, please. And so we decided to fund the first spin-off of Scuola Normale Superiore, which kept the name VIS. And next slide, please, again. So essentially, our tagline, making science beautiful, this is what we wanted to aim at. This is just a little kind of a mosaic image of what we started doing in 2019, when actually the company started. Essentially media for science dissemination, communication. We say not just science, well, science in the broad term, knowledge, let's say. Next slide, please. So what we mostly produce is, as you could see, videos of all kinds and all that belongs to the world of extended reality. So the peculiarity of our idea was that we would cover the entire mission, let's say, so from understanding the scientific concept, because we came from research, to the public engagement adaptation, the creative development, and the media production. So to do this, of course, we had to gather a lot of skills beyond the one of scientists and the science communicators that we were, but we were able to do that. Next slide, please. So this is the team that combines the skills. These are our main collaborators, but we have other production teams depending on the project. Matthias Guerra is an associate of the company. He's the creative director, and then we have a very large industrial partner that gives us, let's say, producing productive power. Next slide, please. And of course, we work with all those that produce science and knowledge. So mainly research and education, universities, research institutes, international collaborations, also museums, festivals, planetarium, and also some companies that are really into R&D. Next slide, please. So these slides, I don't know if they're available to the participants afterwards. I will not talk about this because I have no time. But this is just to say that to enter more into the topic of the talk, that immersivity and interactivity are really powerful tools. And so there is a whole lot of publications that explain why. There are a lot of studies. It's really like a topic that is investigated thoroughly in the last years. So these, if they're available, I hope so, you can have a look at all the reasons for which being inside something 3D works very well for learning, for retention, for the emotional impact, and so on. Next slide, please. Yeah, this is an example of one of the publications on how effective, for instance, here is a 3D interactive microbiology laboratory. Next slide, please. And this is one of the part of the research in all this field is the learning models. So there are studies on this how interactivity, physical presence, agency are all factors that really enhance the power of the communication tool. Next slide, please. Next slide, please. So here are just a few examples. So we will grow, let's say, in immersivity. So this is not actually immersive. It's just an example of our production that we did for the Center of Space Studies of Catalonia. So this is a film, which is both animation and live action. It won several prizes. It's about the role of the role of the importance of education, early education for girls to pursue a career in STEM. And it talks about Jocelyn Bell, the case of Jocelyn Bell, and it's mostly about pulsars and other compact objects in the universe. Next slide, please. This is a documentary, a broadcast documentary about dark side. It won the National Geographic Prize in MIA. And it's a traditional documentary for broadcast. Next slide, please. And here we get immersive. So all the immersive things I'll describe now are actually, you can experience them in the coffee break room. So this is Daphne. It's a particle accelerator. It's a collider, matter-antimatter. And you can become an electron and do the whole tour of the electron in the booster, in the accelerator. And of course, by being an electron, you learn a lot about what happens to the electrons in the accelerators. And this is a 360 video, so it's not interactive, it's just immersive. It's 360 degrees, but it's a video. Next slide, please. Here is one step further in the let's say, ladder of extended reality. So this is still a 360 video we did on Galileo, the live, the discoveries, and the trial. But it's actually thought to be displayed in a museum. So it's what is often called a hybrid experience. Next slide, please. So essentially, the Galileo Museum in Florence is a traditional museum with ancient objects. And 4 VR stations are there now with this experience that really adds an extra dimension to the museum experience. Next slide, please. Galileo VR, actually, we brought it also in Expo Dubai. Okay, 3 minutes. In Expo, sorry, not Dubai, Osaka. And next slide. It was a very nice experience. We did it in 9 languages because it's in a museum which is very international in Florence with a very international audience. And so we did it in 9 languages, among which Japanese. So it was very fitting for the Expo in Osaka. And there were schools. And we did a very nice activity. Next slide, please. So this is heat. This is the main, let's say, topic. This is a project that goes much higher in the ladder of complexity in extended reality. Next slide, please. It's a European Horizon funded project. It has a 7 million budget. We are one of the 14 partners in the project. And we are the leaders of the XREL pilot. So XREL is a lesson. It's a hybrid extended reality immersive multi-sensory lesson. So that means that a lot of things happen. So there is a teacher, there is a classroom with actual people in presence. Then there is a remote user. And it's hybrid in the sense that the in-person and the VR, they see each other by holograms and by direct contact by voice. So they interact in lifetime. So the VR user sees the hologram of the teacher, and in the class they see the hologram of the VR user. And so the lesson happens in this hybrid way with also multisensory inputs. The lesson is about the solar system. Next slide, please. So it starts with the sun. So the sun scene, the teacher talks about the sun, the inner structure, and so on. As the scene develops, the sun gets close. And the VR user, and also in the class, they feel the heat because there is an infrared lamp that gives the sense of heat as the sun gets closer. So that's really, of course, has an impact. Next slide, please. Then we go to Mercury. We reproduced in a very detailed way the surface of Mercury. And the user can grab Mercury with the haptic gloves and feel the texture, feel the fact that one surface is very cold and one is very hot because the temperature feedback is there. Next slide, please. And then the final scene is Mars. So this is different. Suddenly the user finds himself on the surface of Mars. And here there is olfactory feedback. There was a talk before about that. So there is the Mars scent, which is because of sulfur and iron oxide. It's essentially a mix of rotten eggs and rust. And so there is a scent dispenser. So during the virtual experience, the user smells Mars. And also this has an effect. Next slide, please. We are testing all of this effect with the quality of experience protocol and the multiple forms to try to understand what is having the most impact between the multisensory inputs, the immersivity, the interactivity, and so on. Next slide, please. Yeah, these are just, next slide again. I won't talk about this. Next slide, please. Thank you, these are my contacts. Thank you.
That's a good slide. Right, thank you very much, Marcos. I don't see an online question, so let's take one from the room, if there is one. Annie, otherwise I can. I have one quickly. I have one. The accessibility of this, I mean, how easy is this to translate? Obviously, there's a physical aspect, so you have to physically go to the school and do an installation, to roll it out to other countries and other places. What is the plan?
Yeah, this is all experimental. The TRL is not high, so it's all like pushing the boundaries, and then all these aspects of accessibility, portability, and so on will be taken into account. Of course, the previous things I talk about, they're very easy to bring because you just need a headset, but this needs a lot of hardware. So
okay, understood.
Thank you very much. So, I mean, it's kind of related, but not really the same thing. So, even for the first ones, you need the headsets. But what you're developing is the content. Like, if you go to different schools or something, schools are expected to buy their own headsets, or funding is needed from different public organisms, or where the money comes from for that part.
Yeah. Well, for instance, in Italy, we know well about Italy. There was like a program from the Ministry of Education to give schools hardware, and so a lot of schools bought headsets and they don't know what to do with them. So actually we're solving a problem there. We're giving them some content. So we have to get to the schools, which is not that easy. But actually in Italy, there is the opposite problem. I don't know about the rest of Europe or other countries, but in Italy, this is the situation. So actually, we thought it would be a good idea to give some, very often the teachers come to us and they say, we have 5 headsets or 10 headsets, but we have nothing to show. Do you have something? So this is, yeah.
Do one more. Sorry.
Thank you so much. I wanted to propose a very hard question. Oh. Here we are in the Middle East, and there is a different underprivileged locations. My kids, young people interested to use the virtual reality. How you as a science communicator or science visualizer can reach out to those persons who cannot access to this sort of technology for the low-tech environment. To actually engage their community, because this is really important, and the world is not world for the rich people, except for those kind of the people who are really interested in this sort of technology.
Yeah,
experience.
So you mean for those that cannot access the virtual reality headsets and so on? This was the question, like how to get to the people that are not able to buy one, or well. Of course, the easier all the contents we do usually also have a 2D version, so you can access it's just videos. So the same content can be also you can see it on a mobile, which almost is of course much more widely distributed. To get to the people that have the headsets, we count on getting access to the marketplaces so that people can download the contents from the store. But of course, it's still a technology that is not widely available, so of course that's an issue. But yeah, thank you.
Okay, just in the interest of inclusivity, there was one online. Just a quick one. How are you dealing with the time lag between the VR user and classrooms? Connectivity.
Connectivity. In the network, there is one company that has a dedicated tool for that, and so that is called Holomit. That allows for the data management of the whole thing. So it's a complex process, of course, because in the classroom there is the holographic fan. You know, this big bell thing, and inside you see the VR user, while of course it's much easier to send the hologram of the teacher inside the cosmic scene that we created. And for the audio also, there is this system that manages that very well. So it's a thing that is part of the project.
Okay, thank you very much.
Thank you.
And thank you for the questions. All right, next up we have Andrea Muñoz-Gutiérrez, who is speaking on 700 Voices, One Universe, Communicating Cosmology with the DESI collaboration. Thank you.
Okay, thank you very much. Thank you for the organization, also for having us here. Actually, the name of this presentation should be updated to 900 voices instead of 700, because this number has changed since we applied for this talk. Can we go to the next slide, please? Wherever. Okay, so first of all, what is DESI? So DESI is the Dark Energy Spectroscopic Instrument. It is a spectroscopic galaxy survey that is measuring the effect of dark energy on the expansion of the universe. So it will obtain, or is obtaining, tens of millions of, spectra of tens of millions of galaxies and quasars, and constructing the largest 3D map of the universe ever made by humankind. This instrument is installed in the Mayall 4-meter telescope in Kitt Peak National Observatory. It is made of 5,000 robotic fibers operated individually and taking spectra simultaneously. Next slide, please. But also, who is DESI? So I said it's 900 voices. So this map, the largest map of the universe, of course, needs a lot of people involved. So it brings together more than 900 researchers, including 300 PhD students from over 70 institutions around the globe. You can scan these QR codes and see, meet a DESI member. So you can see some cool stuff about the members of the collaboration and also visit the institutions in this Google Earth QR code. Next slide, please. Okay, so at this scale, beyond the science, communication, of course, become an integral part of the collaboration itself. So we have a dedicated 11-member Education and Public Outreach, EPO, committee working on developing material and working alongside the science to connect DESI with diverse audiences. And all these efforts are carried out by volunteers within the collaboration. Next slide, please. Tohono O'odham Nation. The Tohono O'odham Nation is the place where DESI is. The DESI collaboration is honored to be permitted to conduct astronomical research on Iolcam Duag, Kitt Peak, a mountain with particular significance to the Tohono O'odham Nation. We have events and material that we prepare with the nation to reciprocate the fact that we are able to conduct our observations there. So we have open nights at Kitt Peak where the people from the nation go and visit the 22 different telescopes that we have at the observatory. They have rodeo fairs, and we try to engage also with local youth and schools. And this is also ongoing cultural exchange with the nation. Next slide, please. One of the examples of this is Baoban. Baoban, if you see the logo of our collaboration, our instrument, there's a little coyote. And this is named Baoban. The name of this figure that is our ambassador, our EPO ambassador, helps us to communicate science with the general public, was named together with the youth centers. And here are some pictures that you cannot see very well, I apologize, about several events that we do at the Toronto Nation. Next slide, please. Okay. I also want to talk about 5,000 Eyes, Mapping the Universe with DESI. This is a full-dome planetarium film produced with Fisk Planetarium, directed by Claire Laman. And it shows how we make this largest map of the universe. How the DESI survey maps galaxies to study dark energy and cosmic expansion. We have premieres organized in many places by DESI members. It's already available in several languages, and it's being translated into more. Next, please. The impact that we have had is that we have been registering over 400 downloads in 58 countries. This number is from last year, July last year. So these numbers, of course, have increased. And also, we have learned that some of the systems already come with the movie included. So if you want to know more about this, please talk to me afterwards. I will share a link with you. If you don't have a dome, you can have the 2D version. It's available on YouTube. And if you feel like hosting something else, you can talk to me afterwards. Please, next slide. We also have a project that is called DESI High, School of the Dark Universe. So DESI High is a computer programming, cosmology and computer programming skills. It's a set of Jupyter notebooks, 8 Jupyter notebooks, so that high schoolers and college students will have experience with the codes and using actual DESI data. And we have several events, and these events are also hosted by DESI members. So the people who are taking these courses will have the experience of working with real DESI data, with real DESI scientists. And this is something that has a very good effect, and people get very excited about it. And it's being translated into multiple languages. Next one, please. So about DESI's digital reach, because this is something that we cannot stop talking about. This is our website. Maybe the resolution can't, you can see it very well, but it's hosted at LBL. If you go to the website, there's a tab that says Education and Outreach, and then there you can find all of the material that we make. And in this map, you will see the impact that this page has had, especially from last month. Why last month? Because last month we reached a milestone. That is, we completed the original 5-year survey. It's now extended to 8 years. But it was a big thing in social media, and it was very mediatic. So this is what we have last month. Next one, please. This is also the metrics about this. The DESI surpasses 5-year survey, also data release 2 results. This is a guide through the paper, so we don't only do this thing for the general public, but also for scientists who would like to know more about what we do in the collaboration. Next, please. We have to talk also about social media, of course. I don't have to convince you about how important it is to have social media, and that this is a super easy way to connect with the people. And it is something that makes research more accessible, and we can show also behind the scenes and how we do this work on a daily basis. And we have over 10,000 followers across platforms. And here you will see in this QR code all of our material for not only social media, but also the website, etc. Next one, please. We also have outreach resources for events that are in person. So we have 3D printed models and tactile visual aids. which are designed not only to support science communication in museums or in schools or classrooms, but also to improve accessibility for blind and visually impaired audiences. So this will make cosmology more inclusive and engaging through this exploration. These are concepts that are very abstract, very hard to explain sometimes. So all these aids are a very good way to support our talks. Next one, please. And among these resources, we have these super cool glasses. I have some here, so you can see how the DESI instrument sees the world, sees the universe. We have stickers. We have some of these things available in conferences. So you may have seen some of these at AAS or these kinds of meetings. And there's also a fly through the DESI data that you can play with if you visit this site. Next one, please. And thank you very much to our sponsors, 72 participating institutions, the organization of this conference, and you for paying attention to my talk.
Thank you, Andrea. While I wait for any online ones, do we have any in the room?
Thank you for your talk. I'm very interested in intercultural dialogues and conversations. Yes. And you previously mentioned that you were honored to be permitted to have the experiment on the mountain. Could you tell us more about were conversations with the Tohono Nation people?
Yes, with the Tohono Nation. What exactly would you like to know about? Yes, so this is a sacred land for the Tohono Nation. So NOAO, previously NOAO, now it's NORLAB, got in the dialogue. This observatory has been there for a long time. It's 22 telescopes. And the nation administrates all of the resources there. So there's constant cultural exchange or just exchange and dialogue with them, so that we can perform our work there. And they are included also in the activities, outreach activities at the visitor center. There are nights that when they are allowed to go freely and spend time there, even have markets. So we also engage into outreach activities in schools.
But the land belongs to them or to the very nice. You should write about this because there's very interesting
we can
practices.
Talk more about this. I am not a part of NORLAB, so I don't know about the origin of this communication. But yes, even when you go to observe, you see that this is something that they handle.
Thank you.
Even the time zone is different there. Even in Arizona, they have things different. Yeah.
Just a quick question.
Yes.
This is exactly about the intercultural communication, because there is a theory about how the language shapes the way we think. We talk about the nation. I wanted to actually translate all of your material, because you show the data from different parts of the world. Show this material to another people. Some people, because of the different term, different concept, they can actually understand this, for example, concept differently. For example, if you show this dark matter to the indigenous people of Australia, because they have their root with the sky, maybe they understand completely differently from the dark matter, because the language shapes the way we think from the any term, and this is something theoretical.
Yes, this is actually a challenge that we are facing. When we develop the material for high schoolers, this is, I think, one of the most difficult parts. In many of these communities, these terms don't exist. So we have to either create them or try to use their language to transmit the correct concept. This is something that we are considering, that we're working on. Mm-hmm.
All right, thank you very much, Andrea.
Thank you.
And thanks for the questions.
By the way, there are stickers on that table and some of the very cool glasses.
help yourself to stickers after the show. All right. Thank you, everyone. The next four talks are going to be online. First, we have Luis Salcalda, who will be talking on the ELT Explorer, an interactive game and virtual visit to the world's biggest telescope. Thank you, Luis.
Hello, good afternoon. My name is Luis Calçada. I come from ESO, the European Southern Observatory in Germany. I work in the communication team as a visual artist. As you might know, hopefully, ESO is building the ELT, the Extremely Large Telescope, in the Atacama Desert in Chile. The ELT is going to be the world's biggest optical and infrared telescope. It's planned to start operation in the end of this decade. So what is the ELT Explorer? So it's a first-person, virtual, realistic, and interactive visit to the digital twin of the ELT. We had a video prepared, but apparently it's not working on the presentation, but I think Cynthia will be kind and put it on the chat, so please have a look at the video we had prepared so that you can have a clearer view of what the ELT Explorer is. So what it's not, it's this video, it's not a pre-rendered video, so it is a real-time application, a PC, Windows application that you can use using an Xbox controller as if it was a video game. So so the entire digital copy of the ELT can be visited, interacted with. You can walk, you can fly around with a drone, and learn about it. So what is our vision? So we want it to be a dual-purpose educational platform. So in one hand, it's aimed at people like you, educators, people that work in planetariums, people that work at science centers, teachers, and we want them to explore the ELT with their audiences. Freely walk around the gigantic observatory, use the pre-made and pre-narrated tours that we have made, and think about use cases like planetarium shows, virtual tours in school classes, or experiences in science centers and exhibitions, for example. On the other hand, we also wanted to be, or imagine it could become a fully quest-driven video game, using storytelling and gamified problem solving, aimed at young audiences who would like to play video games. And for this, we're pursuing funding opportunities, because this is not something we can build in-house, but we've developed the infrastructure to make this vision, this idea of creating a video game, a reality. So we imagine distributing this freely, of course, for free, and widely via game stores like Epic Store or like Steam, which are stores where people can find video games like I imagine your kids find Fortnite or Rocket League, for example. So where we are, so the ELT Explorer started as an experiment. So we wanted to leverage the entire 3D engineering model that our colleagues building the telescope have available. And we would like to try to make it available to the public somehow. But a big telescope means that there's a big challenge, because every screw, every bolt, every little pipe of the ELT is there in this model. So we started prototyping, experimenting what could be imported, what could be simplified, what could be interacted with. And this brought us to the alpha version that we have available now and want to present it to you. So where do we want to go? As I mentioned, potentially developing this into a video game, a standalone video game, narrative-driven, quest-based. But for this, again, we're seeking funding. And we don't just want to make a game for the sake of making a video game, because we wanted to reach a broad audience. We want to create engagement. We want to use the gameplay to enhance science education. And we want this young audience to learn and potentially even inspire them to pursue STEM field careers. But that's the game. In terms of the educator, what we call the educator module, how we plan to expand it. From the alpha version we have now ready, we want to include more narrated tours. We want to include develop further a full-on version, because we already started working on this. We want support from languages. We want potentially that educators, people like you can create their own tours. We want to develop character customization, VR, which is already in development, and of course, importantly, also your input. If you choose to give it a try, use it with your audiences, then we would like to get ideas from you, right? We've already had the chance to let some audiences experience it in a couple of open house events in ESO headquarters in Germany and in Chile, and also in a couple of science conferences. So very quickly, let's have a look at the technology and the challenges that we've faced and we're facing. So this is developed with Unreal Engine. Unreal Engine is a real-time game engine used to develop many of the popular games, like I mentioned, Fortnite, Rocket League, you name it. A big percentage of games are being done using Unreal Engine, but also architecture, cinema and TV, automotive industries are also using Unreal Engine for visualizing buildings, cars, etc., etc. And a lot of its groundbreaking technologies allowed us to create the ELT Explorer. So one of the core technologies of Unreal Engine 5 is Nanite, you see on the top left corner. And this was fundamental because it allows us to import highly detailed and complex models from the ELT and display them in real time. We're talking about thousands and thousands of different parts and millions of polygons. This wouldn't have been possible. Unreal Engine also let us create a realistic landscape of the Atacama Desert, as you can see there. Also realistic real-time simulation above the ELT. That can also be possible. Also rendering hundreds of lights, which we need to light the entire dome of the ELT. So the alpha release. So this is the version we currently have prepared. Hopefully in the next coming weeks, we would be able to give it out to people who are interested in trying. So what do we have in the alpha version? The full telescope is there, the full infrastructure. You can walk, you can climb, you can fly using a drone. You can interact with the telescope via menu system, open the doors, windshields, mirrors, lasers. There's already there. It's quite fun already to play with it. But you can also experience some pre-narrated tours or guide your audiences yourself, giving them a tour of the ELT if you know about the observatory. You can change the night sky, experience the sunset, and experience the massive scale of the telescope. But importantly, what do we expect from you if you choose to give it a try? It's a work in progress, right? So it is heavily in development. There's a lot of bugs, so we know this. So help us find them, test the tours with your audiences in the classroom, in science centers, and share with us ideas for future tours or even future features of the ELT Explorer. We have a couple of tours implemented right now, but this is just a work in progress, right? So the first core ideas. So we want to build a community that helps us share the excitement of the gigantic telescope. Very quick mention of the team. So the core team, there's 3 people at the top, is myself. Juan Marrero is an engineer actually building the telescope as well, and he's helping developing the ELT Explorer, also the VR part. We have a student game developer who's also working on the project. So we're pretty much working on this as a side project for the past 2 years, 10-20% of our time. And then a lot of people in the team also mentioned they're helping us in consulting, writing, and advising in general. So if you're an educator that would like to try the ELT Explorer in its current alpha version, visit elt.eso.org/explorer, get some more information, and then contact us if you'd like to try it. One thing which is very important, you will need a very good gaming computer. For now, we only support Windows, of course, Mac in the future, but for now we're focusing on Windows. But you will need a very good gaming computer, one which has a gaming GPU. So that's so thank you very much, and please visit the website we prepared. Thank you.
Of a GPU these days, it's not easy. Do we have any questions in the room? There's one at the back there.
Hi, thanks very much. So you said the telescope is going to become operational at the end of the decade, if I understood that correctly. I wasn't quite sure. And if that is the case, how do you see the evolution of the game? Once the telescope is operational and producing results, do you have any sort of strategic vision about how the evolution of the service will continue?
I mean, for now, we're focused on creating the excitement, right? So we want people to visit it, to understand the scale, to get excited about the technology, the instruments, and this is what we're focusing on right now, right? Of course, like I mentioned, we are really welcoming ideas, because what we've built so far is the infrastructure. So the digital twin of the telescope is there. We want to transform the application into like a walkable museum, right? That you can walk through the telescope and learn about the parts. But it is a very good point, in the future, including the science which is being done. But yes, I mean, these are all ideas which are possible because we build the infrastructure. So we're very welcome to receive input and get ideas. But for now, we're still not considering that.
All right. Thank you. There's just one question online, Luis. Can you also share the link, please, for the video that didn't play? Maybe in the chat.
I think someone already did. Annalene Begena, she shared the link, and you can also have a look at the teaser that we shared, and also a sample of the tour, one of the tours we have prepared. And again, this is just one of the many tours we would like to include to explain, show about all the systems of the telescope. So please visit it. Thank you.
Okay, thank you. Just one last question from online before we move on, Luis. In terms of people who don't have access to a gaming computer, educators and the like, would you consider setting up some sort of cloud-based access?
Yes, absolutely. I mean, thank you, Mari, for the question. It's a really good one. Of course, it's as if I think someone was saying that getting a good GPU nowadays, they're very expensive because precisely of AI. But maybe you'll need to borrow your kids' computers, I guess, because they have computers that can run games. But yes, definitely, to go back to the question, we are considering, because there's some companies doing cloud-based rendering, so that would be a great solution. We have looked already at some possibilities, and for sure, I think this will be a possibility. We have to look into costs, of course, of supporting that.
All right, great. Thank you very much again for joining us, and thanks for speaking with us. Okay, next up we have another online talk from Magda Jakubiak from Poland, and she's going to be talking or giving some lessons from creating a new institute for particle astrophysics. Thank you, Magda.
Hello, everyone. My name is Magda Jakubiak. I'm a communication specialist at the International Institute for Particle Astrophysics, Polish Academy of Sciences. And in short, I'm going to call our institute, as we are calling it within ourselves, AstroCent. And I am going to talk today about the strategic communication and outreach from day one, lessons from creating a new institute for particle astrophysics. And the co-author of this presentation is Julia Hojka. But first things first, it is fairly important to say that we are a young institute, as officially we were established in February this year. Our journey started, though, in 2018, when AstroCent was created as a research unit within the Nicolaus Copernicus Astronomical Center of the Polish Academy of Sciences. And we were created as a result of the funding from the International Research Agendas program of the Foundation for Polish Science. Today, we are the International Institute for Particle Astrophysics, Polish Academy of Sciences, the first of its kind in Central and Eastern Europe. And you are right to assume that our communication and outreach changed during these 8 years. So I would like to say something about our beginnings. The beginnings were a little bit difficult. We had, in 2018, we had no strategy, no visual identity, no dedicated team or even a person responsible for promoting our work. The communication tasks were added on top of the administrative duties, and materials were created only when necessary. So as a result, every project and event had its own look, which was really interesting from the creative point of view, but a little bit too chaotic to actually show the world the unified vision of AstroCent communication. But this was the beginning, and I am happy to say that the time and growth came to our help. As our research were growing and our team was growing as well, our scientists were more and more engaged in showing the science to the public. So AstroSend began taking part in major outreach activities and events in Poland, such as Science Picnic and the Night of Museums. But of course, we have been organizing our own initiatives as well. And one of them, I would say the most important to us, was the organization of the public lectures in 2023, when we invited to Poland, to Warsaw, the Nobel Prize laureates in physics, Professor Art MacDonald and Professor Barry Barish. It was possible thanks to our director personal contacts, as both of the laureates have been supporting the idea of AstroSend for years. And Art MacDonald visited AstroSend for the first time in 2019 on the occasion of the Particle Astrophysics in Poland conference. And not to lie, it was a very demanding moment of our activity, but I think worth it. We hosted a very big audience, received a visible media exposure, and gained recognition from the Polish people and the international scientific community. So this was one of the most important factors to push us to think with a clear direction and purpose about our communication and outreach. And this other huge factor was our growth of scientific growth. With time, our researchers started receiving more and more grants from the European Union, the Polish Ministry of Science and Higher Education, and the National Science Center in Poland. And what all of these sources of support had in common is that the dissemination of the projects had to include outreach and communication activities. And this obligatory step created a very specific need, such as establishing rules of graphic designs of the materials presented to the public, or preparing the logo of AstroSend, or implementing the checklist for the text formulas that had to be placed along with the presentations and articles and interviews, etc. So the dissemination of the projects actually forced us to think of the bigger picture. And with that understanding that the promotion and communication activities are important and valued, came the change of the mindset of the team of the scientists and of our directors. Okay, so next, some important steps were made. A dedicated communication specialist was hired, and that person is me. And with this hire, a communication office was created, with Julia Hojka serving as the head of our communication office. We have also written a long-term strategy plan with all the important KPIs and activities for the several years ahead. And on top of that, we, of course, formulated short-term goals and achievements that are keeping us on track. And we are talking here not only about the regular meetings with the institutional partners to discuss the process and progress and challenges, but also some smaller and predictable actions, like publishing at least 2 posts per week on social media to keep our algorithms alive. And right now it feels like we are going forward with a clear purpose. So at this point, it was only natural for us to take the next step and create our own visual identity for AstroSend and the new independent institute we are now becoming. So we went on the full creative journey. When starting this process, we asked ourselves the most important questions about how we want to be perceived by the public, by the community and society. So we took our time to remind ourselves our values and how we want to be recognized for. And you can see the result here on the right side of the slide. I really hope you like it. For sure, it gave us a strong base to grow our communication and outreach. And what is also worth mentioning here is that this kind of process is a very unique and incredible opportunity to involve and engage the whole team. In our scenario, the communication office and the management were the most occupied by this task, but we did reach out to our research team to pick their brains a little bit. Okay, so we had our foundation, and next we started building our brand and showing AstroSend to the world further. We built the new website, adjusted our social media channels, and made sure everything was coherent with our new logo, putting emphasis again on showing our identity and values. And in this stage, there is another important and, to be honest, extremely dynamic step, which is putting us on the network map. Because we do realize that science needs cooperation within fields and institutes, which is why we are not only involved in the Polish Academy of Sciences community, we are also reaching out to media, cultural agencies, businesses, our funding institutions, and the other scientific partners and collaborations. And of course, presenting our institutes to the science communication community, as we believe this is all our support system. So when I started my presentation, I told you where we were at the beginning, but we are 8 years later. So where are we now? I just wanted to sum up some of the most important lessons we have learned and to share it with you. So one, why write and implement a strategy from day one? Because for sure it will take some stress off, and hopefully it will create a clear path of communication activities to follow through the years ahead. Two, make the visual identity your friend. And what I mean is to make sure it helps you navigate your mission, vision, and values through the visual style. Three, think about the future and the relationships. And that corresponds with the four. Four, create your network. Find your paths within the network of institutions, of media and businesses, and create a smooth exchange of experiences, learn from each other, receive support when needed. And five, for me, the most enjoyable one, join popular science events, as this is probably the most fulfilling way to give back to society for supporting the development of science. Okay, so here it is. Thank you very much for listening. And I'm very sorry I was not able to be there in person.
Thank you very much, Magda. Your first challenge as a communication specialist, there's a question online right at the beginning. What is particle astrophysics?
That is a very complicated question, and I'm afraid I am not a scientist to explain that very deeply.
Okay, we'll get into it a bit later, maybe. All right, are there any questions in the room? Not about physics.
You were talking about thinking about your messaging, and I was just wondering for AstroSent, since you're in Poland, did you also have to think about what, in Polish, is there a way the acronym works as well or anything like that?
Can you elaborate a little bit? What do you mean?
I'm just wondering, right, there are acronyms, right, where we change it for different languages just to translate the words. And so I was wondering, when you were coming up with the name AstroSent, was there any consideration of how it worked in Polish? Maybe this is a bad question. I don't know.
Okay, because as the name AstroSent is actually kind of translatable to Polish, because astrophysics, the beginnings is also in Polish, the name, and then the center is, it is translatable to Polish. So it was just something that works both in English and in Polish, the name, if I understand correctly the question.
Yes, I think that was the question. That's good. Anyone else in the room? All right. Then thank you again, Magda. We really appreciate you joining us.
Thank you.
Congratulations.
Good day. I am Joyful Mdhluli. I'm with the International Astronomical Union's Office of Astronomy for Development. And
all right. Next up, we have somebody from South Africa, a good friend of mine, Joyful Mdhluli, and she'll be talking about communicating astronomy for development, multidisciplinary approaches across the OAD projects and flagship initiatives. Thank you very much, Joyful.
Good day. I am Joyful Mdhluli. I'm with the International Astronomical Union's Office of Astronomy for Development, and today I will be speaking about the multidisciplinary approaches across the OAD projects and flagship initiatives in terms of communicating astronomy for development. At first glance, astronomy may seem disconnected from the challenges we face on Earth. poverty, inequality, education, or climate change. But astronomy is far more than the study of stars and galaxies. It inspires curiosity, creativity, and hope. It encourages young people to dream bigger, strengthens education, connects cultures, and reminds us that we all share the same sky. In a world often divided, astronomy gives us perspective, showing us not only how small we are in the universe, but also how connected we are to one another. At the Office of Astronomy for Development, we explore various ways in which astronomy can be used as a tool for societal benefit. The Office of Astronomy for Development is a joint project between the International Astronomical Union and the South African National Research Foundation with the support of the Department of Science, Technology and Innovation. The OAD celebrates 15 years this year and continues to be driven by the mission of furthering the use of astronomy, including its practitioners, skills and infrastructure, as a tool for development in every country by mobilizing the human and financial resources necessary to realize the field's scientific, technological and cultural benefits to society. In addition to being based in South Africa, the OAD also has a global reach where we have established 11 regional and language offices that carry out the mission and mandate of the OAD in the various parts of the world. One of the ways in which the mandate of the OAD is implemented is through an annual call for proposals that is carried out every year. To date, we have supported 254 projects in 111 countries, invested 1.5 million euros, as well as reached over 2 million people. This is a geographic representation of the projects over the years that we have supported. This image also shows us the various places in which astronomy has been communicated to the public. At the core of every Astronomy for Development project is astronomy communication. Each of these project leaders has introduced astronomy to the various communities that they have worked with, and in the next few slides, I will be highlighting some of the ways in which they have achieved this astronomy communication. In addition to the annual call for proposals, the OAD also has flagship projects. So another way in which we communicate astronomy is through these flagship projects. The OAD has identified 5 key themes that encapsulate the concept of astronomy for development. And these themes were selected in early 2019 based on our experience in supporting projects and reviewing more than 1,000 proposals. These themes represent some of the most effective and successfully tested applications of astronomy for development. The majority of the projects funded through the annual call for proposals align with these themes. From the 5 themes, the OAD has 3 flagship projects that fall under 3 of the themes. So the first one looks at stimulating local economies through astronomy, and this is achieved through astrotourism. And the second one looks at using astronomy for mental health, and this is using astronomy for mental well-being as well as celebrating our common humanity. And then the third theme looks at skills development and leveraging astronomy-related expertise to address global development challenges, and this is through our Astronomy Skills for Development flagship project. The projects supported by the OAD communicate astronomy in ways that go far beyond traditional science outreach. Rather than only explain astronomical concepts, they use astronomy as a bridge to education, culture, well-being, technology, tourism, and social inclusion. Some of these ways and approaches will be discussed in the next few slides. Many of the OAD-funded projects connect astronomy with local cultural heritage, oral traditions, and indigenous sky knowledge. This makes astronomy more relatable and helps communities see their own histories and identities reflected in the night sky. Projects often involve elders, storytellers, artists, as well as local historians alongside scientists. This approach shifts astronomy communication from just being a teaching science to co-creating knowledge, which is better received by the participants and audience of these initiatives. Astrotourism is one of the OAD's most innovative flagship areas. So astronomy is communicated through immersive experiences rather than lectures alone. And this includes stargazing tours, dark sky festivals, astrophotography workshops, cultural astronomy trails, as well as astronomy-themed ecotourism. In many regions, visitors learn astronomy while also simultaneously engaging with local culture, conservation, and sustainable development. This creates economic opportunities while also building public appreciation for dark skies and science. Some of the other projects communicate astronomy as a tool for reflection, mindfulness, and emotional well-being. Instead of focusing only on the scientific facts, they emphasize awe, perspective, and human connection to the universe, and this is well aligned with the Astronomy for Mental Health and Well-being Flagship project. These initiatives communicate astronomy emotionally as well as intellectually, making it last and stay longer with the participants and audience of these initiatives. Another form of communication is through art-based astronomy communication. So a number of projects have also emerged astronomy with creative arts to reach audiences who may not necessarily engage with the conventional science outreach. So this is especially becoming popular within the science communication space, where we're now seeing a shift from STEM to STEAM, and this would then also include the arts in the sciences. So this transforms astronomy again into a cultural experience rather than a purely academic subject. Instead of relying on professional astronomers, many of the OAD projects train teachers, youth leaders, amateur astronomers, as well as community facilitators to lead astronomy activities. So this basically allows us to decentralize astronomy communication and build local ownership, which is very essential in ensuring sustainability and impact. And some of the activities when we talk about community-led grassroots outreach would include mobile astronomy kits, pop-up sidewalk astronomy, astronomy caravans in rural communities, peer-to-peer astronomy education, as well as community astronomy ambassadors. OAD-funded projects are often implemented in low-resource environments, leading to very high creativity when it comes to communication strategies. So this could include, communicating astronomy via WhatsApp or community radio, virtual telescope sessions, low bandwidth online learning, or even offline completely, but also DIY telescope building workshops and portable planetariums. These approaches prioritize accessibility and inclusivity, which is very important within the science communication space. One of the OAD's most distinctive innovations is framing our work around the United Nations Sustainable Development Goals, and this also then includes astronomy communication around the United Nations Sustainable Development Goals. Projects communicate astronomy through various themes such as gender equity in science, education in STEM skills, environmental awareness, youth empowerment, global citizenship, and intercultural dialogue. This positions astronomy not only as an isolated science, but as a tool for societal development. Citizen science and participatory engagement is very important when it comes to communication. By making people participate in the activities, the knowledge stays with them longer. Many of the projects actively involve communities in doing astronomy rather than passively receiving information. Participants then become contributors to science, while at the same time strengthening engagement and the ownership within the activity and the program being implemented. Perhaps one of the most powerful innovation communication tools across the OAD initiatives has to be the intentional use of awe and cosmic perspective. Many of the projects communicate astronomy as a way to inspire curiosity, humility, as well as peace and a sense of shared humanity. This helps audiences connect astronomy to broader questions like who are we, how do we relate to one another, what is our place in the universe, and how can science build a better future? In this way, the OAD projects communicate astronomy not only as knowledge, but also as a human experience. At the end of the day, science communication is not about a teaching, but rather about finding various ways in which you can connect with connect the content with the people and the audience you're trying to communicate with. At the OAD, since our projects are focused on the people, project PIs are inclined to understand the needs of the community and thereafter tailor the projects accordingly. So in conclusion, I'd like to invite you all to join us as we continue to use astronomy for a better world. I would like to invite you to submit a proposal to our 15th annual call for proposals and make a positive contribution to society through astronomy. Thank you for your attention and your time. I'll take questions now.
All right. Thank you, Joyful. So Joyful is available online, and you have 6 days to put together your proposals. So we'll try and finish soon. Do we have any questions in the room? Yes. A microphone. Yep.
Thank you so much. Can you talk a little bit more about the astronomy caravans practice in rural communities and what that looks like?
No, I can't give you any more information on that specifically, mostly because the projects are not implemented by the OED directly, but through our projects. But I'm happy to find the links to the project so you can get more information on that.
There was another one at the back. Yes.
Yeah.
Oh, you got it.
I have a question regarding the funding because I remember the country like Iran. I think it's 7 years ago, one of the projects from the IAU called for proposal for COVID-19 in 2019. One of the Iranian received the funding from the OAE. But, because of your cooperation, you're outside of the Middle East. And when you wanted to transfer the funding inside of the Iran from the Muscat, Qatar, the fund is get back to the IAU because, Iran is part of the sanction. So how the IAU, as part of the international organization, both the headquarters and the OAE, can help a couple of the country that they have some sort of the pressure in terms of the political situation to sort, this sort of the problem, to transfer their funding and, help them in a better way to push their project.
In the past, we've had people who have applied for projects to be implemented in such areas. But if the project PI is, for example, has a bank account that is not in Iran, we're able to transfer those funds to them, and then they can, maybe find a way to get it to their personal account within Iran. We're always open to having discussions in terms of how we can support the project. But the IAU does have a list of some countries that they can't directly send funds to. But if the project PI is maybe based outside of the country, they can send the money to them, and then they can see how they get the resources and the funds used in those specific countries.
So there's an alternative way to actually choose another country as a PI or grant holder and actually implement this project inside of the Iran, for example.
Yes. So if you are based outside of Iran, but you want to implement the project in Iran and you have an account outside of Iran, we can have some sort of agreement in terms of sending it to your other bank account, and then you can go implement the project in Iran itself.
Great, thanks.
Okay.
Yes, one more at the back.
Thanks. You showed a map with your projects globally, and you also talked about decentralization down to the agents, presumably local agents on the ground. And I've got a question about how you manage and coordinate and how you control all of these agents. Do you have some sort of way of making sure that they're behaving and acting consistently with your vision? And do you face any problems with the asymmetry between what you want to do and what agents actually do on the ground? Just any comments about how you manage and control that very vast network?
So with the map that you saw, those projects, that is through our annual call for proposals. So individuals themselves propose a project and then submit it to the OED. So they are the ones that create their own initiative. So obviously through the review process, we then see that it aligns within the OED goals, and then they get funded. But we can't physically be there. So we hope that they actually implement what they say they're going to implement. And we rely on the reports that they give us in terms of this is what we did. So we basically working on good faith with the hopes that people actually do what they say that they're going to do.
All right. Thank you, everyone. And thank you, Joyful. We have one more online talk. And then just yes, thank you again, Joyful. And then I was just asked to remind you that when the session's finished, there is an informal online gathering too, if anyone would like to join and continue chatting. Just now on to our last speaker for the afternoon, Bethany Downer, who is joining us from Canada and is talking about communicating synergy observations. Thank you, Bethany.
Wonderful. Well, I want to thank everybody for being here today. I know I'm the last thing between you and a social hour, and I apologize that I can't be there in person. First of all, I want to say that this is a joint effort, a joint presentation with myself and Maddie Zamani, who is also online. He leads our image processing team. So we're here today to talk about synergies with different observations across different observatories. We'll mainly be touching on the Hubble Space Telescope as well as the James Webb Space Telescope, as that is the two missions that we work for the European Space Agency. ESA is a mission partner on both Hubble and Webb, and we want to touch on the various ways that these telescopes are able to complement each other. We often like to say now in much of the work that we're doing that this is a transformative era in astronomy, in that it's not often now that we see a press release or a scientific result that is based on the results of just a single observatory. We're now looking at results and data coming to us that's representative of both space-based and ground-based telescopes, data archives, and the science teams are spread all around the world. So in this way, we like to say that observatories aren't competing against each other, but instead complementing each other. We're very much experiencing multi-wavelength science for the astronomy domain right now. So we really want to touch on the purpose and value of synergies across these different observatories. And for that reason, we can see, this graphic is a great example of why observatories are operating at different wavelengths. So they're not necessarily designed to view the universe in the same way, which is why they can complement each other through the work that they're doing. I think Hubble and Webb are a really great example of two observatories that are complementing each other in this way. In fact, when Webb started its science operations for the first 6 months, our social media team used the hashtag BFFs in space when promoting results from Hubble and Webb to showcase that they were working together in tandem. We found very early on in our communications for Webb, when science operations began in July of 2022, that there was a public perception amongst some that Webb was replacing Hubble, or that Webb was the successor for Hubble, when in fact, science teams around the world are delighted to be able to use these in tandem at the same time. Hubble, of course, was designed to observe the universe in optical, but it also does have ultraviolet and near-infrared capabilities, whereas Webb its primary mirror has 6 times the light gathering power, because that's essential for observing at longer and dimmer wavelengths in the infrared. So in this way, they're complementing each other and what it is that they're looking at the universe and what they're designed to do. I really love to showcase this image that we here have of the Phantom Galaxy. This was the first image that our team put out, that ESA Webb published as our very first picture of the month. So this was back in August of 2022. And what's neat about this image that we can see here, Maddie did a phenomenal job. On the left, we have Hubble's view of this spiral galaxy. On the right, we have the MIRI instrument's view to be able to see some more structures and through the gas and dust that was revealed through the spiral in its arms. And in the middle, we actually have something phenomenal in that the Webb and Hubble data was combined. So from our very first image release, we were able to showcase what these data sets can do and how they differ from each other, but also how they can provide a more comprehensive view when combined. So this Phantom Galaxy is a spiral galaxy about 32 light years away. It's one of the most popular galaxies still on our website, so not very hard to find if you do want to take a look and learn more. Something that I like to remind people is that Hubble and Webb were not designed to be operating in the exact same way. And yes, while Hubble is quite a bit older, we just celebrated Hubble's 36th anniversary. They were deliberately intended to be different. And the way that we're able to showcase what it is that we're looking at and something that we really focus on and prioritize is having very detailed metadata as in on each of our image web pages, we will provide detailed information about the filters used, the observation from which it came, detailed information about the target that we're looking at, as well as descriptive text under each image that explains what it is that we're looking at. Audiences are often learning for science through storytelling, and we really work hard on the text that we develop in order to achieve that and to be as accessible as possible for all of our audiences. And in this way, we want to continue to educate people, like on some of the key messages that I showed there on that last slide, in everything that we're doing, in that Hubble and Webb are operating differently, but they can also complement each other. And that's compounded when you add even more telescopes and data sets with that. So I'd like to showcase a few examples today of cases in which that has been particularly successful. What we're looking at here is Messier 106. It's also known as NGC 4258. So we can see what it would appear to us as being a visible image from the ground here on the left. So this was a ground-based observatory that allowed us to have this view. And we like to have call-out boxes to show what specific area we are looking at in more detail. So again, we have a Hubble image now in the middle that's zooming in closer. And finally on the right, Webb's NIRCam instrument was able to provide more detail about the clusters of stars and more detail into the core of this particular galaxy. And then again, a way that we can show Hubble and Webb being complemented by ground-based data. One of my personal favorites that we put out, this is the Horsehead Nebula that was published in 2024. This was a great European collaboration in that we had Hubble, Webb, as well as Euclid. So we were using old data and new to be able to put them together in a graphic like this. So the image on the left was taken from Euclid, and this was published in 2013. This image was taken in about an hour, so it was able to showcase how impressive the data collection can be from this observatory in such high detail in that time. And in the middle, we're looking at Hubble in the infrared view, which is always nice to be able to get a Hubble infrared image, even closer in detail. But then when we were publishing our brand new Webb image in the infrared there on the right, because it's looking at a very specific tiny part of this structure of this target, Euclid and Hubble provide great context as to what it is that Webb is looking at in such detail. And in this way, we find the call-out boxes quite effective to be able to show our audience what it is that they're looking at and what they're zooming in on. If you watch our Zoom videos on our website, you'll see that ground-based data is quite valuable for that, and we're able to zoom in on specific areas of targets. This is another feature from Euclid, this time with Hubble. We published this just in February as part of our Hubble Picture of the Month. Euclid does a great job of showcasing the complexity of stellar death here. And the wide near-infrared view and visible light, I think, really showcases some of the halo fragments. But what makes this special is these two observatories showcasing their data capabilities together. So on the right, we're seeing the core and the details that Hubble is able to bring out, and the call-out box reflects just how much we're able to see in detail of that central area, and was one that was quite popular, and we're still getting lots of interest for this one. So it's really great to see that these have longevity long after we publish them as well. This is the Butterfly Nebula, so it's also known as NGC 6302. We published this last summer. So A and B here, these images on the top are Hubble, but from two different wavelengths. We're looking in the optical and the near infrared, which I think is quite spectacular, that we love to showcase. Also with Webb, having a single telescope, but two different views or two different instruments. Which is really great to be able to showcase the difference. And then here on the right, Webb is combined with Elma, which is another great synergy to be able to have. And we can see that the detail is brought out quite strongly here in the core. And what's excellent is seeing that we were able to work with the science team to bring out some of the details and what are the specific features that are showcased here. I know we are tight on time, so I want to touch on a couple of things really quickly. Of course, we are challenged with AI, particularly with public perceptions. We'll have We'll see images that appear to be generated from Hubble or Webb. These are Flagship missions, so people know that name. So sometimes the public will believe it if it's an image that's artificially generated. We don't find that to be too much of an issue as of now, as we find most of our audiences are looking for the source, especially media. We have great relationships with them, so they know to come directly to the source for their content. Something we're challenged with, though, is that sometimes we do have to use artist impression. If we're showcasing spectroscopy or a scientific result that doesn't have an astronomical image, we will have to use an artist impression sometimes, but we'll use a graphic artist, and we're always very clear if something is developed as an artist impression in all of our texts and all of our communications. Lastly, I just want to show a positive example of AI that we published in January. So there was a European team that trained an algorithm using AI to scour through nearly 100 million image cutouts. And they were able to find 1,400 anomalies. So they were looking at things like gravitational lenses or funky features that normally don't show up in our typical images. And of these, 800 were previously unknown. So this is a really great example of a great result that came. And this is an example of just 6 of those that we were able to develop images for. For those that are curious about how we do our work, this is some of the ways that we develop the images and the press releases that we receive and how that information comes to us and how we develop them. And if you want to take a look at the raw data that comes from Hubble or Webb, which are publicly available to everybody, these are your means of doing so. Of course, everyone can reach out to me if they have any questions or things that they want to touch on, but these are things that we feel are important in the work that we do, that we try to really stay consistent on, and the things that are important to us. It's important that we're already crediting the things that we're sharing. The astronomical images take days, weeks, sometimes longer for every single one that we publish, so it's important that we're always crediting the work that's being done. And the very last point I want to make is that Maddie and I are on a much larger team. It is very much a group effort that we're fortunate to be able to be a part of. So it's a very much larger team that we're representing. But of course, everyone is welcome to visit our websites to check out more of the images that we're publishing all the time, or to reach out if you have specific questions.
And of course, Maddie too. We have a question here in the room.
Thank you. That was really interesting. I was wondering if you can tell us a bit more about how you select the images for your monthly releases. Is that based on science papers, or do you select them for public outreach specifically?
So I'll touch back on some of the ways that we receive our information. So sometimes we receive a lot of science papers for consideration, and we're in the tough position that we're not able to publish everything. Because, you know, the level of science is being shared, and also the resources that we have, we want to prioritize, you know, the really exciting results and to showcase different European science teams. Sometimes they might have a science result that's not selected for a press release, but they have a really incredible data set. We might also be doing data mining. Our team loves looking through the archive. We all like to spend time taking a look for new data. Sometimes we'll have people reach out to us, either from the public or the science teams directly, saying, hey, this is a data set that we have that's quite interesting. But I want to emphasize that the relationship that we have with the science teams, both for Hubble and Webb that have observing times, they know our contact, they know to get in touch with us. And I know Maddie is available too, and to answer questions about what type of data sets that he looks for that are valuable for processing. But it's the relationships, I think, with the science teams that are most important for us, that we've curated over many, many years.
Thank you. Anyone else in the room? All right. I don't see any online. So thank you once again, Bethany and Maddie. And thank you to all of our speakers for the session.